quadratic, right? So what we have today is variation. Let me quickly share this slide. Yeah, can we all see this slide?
Yes, sir.
Yeah, so today we're going to be talking about variation. So let's kick off. Okay, now before I go into types of variation, from the word variation, variation means changes. Yes, even in real life things change. Yeah, and before I continue, please, I want to wish everybody happy Valentine's Day. Some of us we went out, some of us we didn't go out, but it's fine. Happy Valentine, everybody.
Yes, thank you, sir.
All right. Okay, so as I was saying, we're talking about variation. Variation actually, ideally, or literally means changes. I want to understand how things change, right? Yes, if you go to the market, you find out that the cost of goods in the market last year is not what it is in the market right now. There are changes. Some have gone up, some have come down, right? It depends on the part of Nigeria where you are. Cost of living, the same thing, and other items, right? Even for fuel price, maybe we'll use fuel price now as an instance. So you see that as time changes, or as the year progresses, the cost of items fluctuates. It's either it's going up or it's coming down. That's what variation is all about. So I hope it's clear to everybody, right?
Yes, sir.
All right. Okay, so now I want to look into types of variation now. Now there's something we call direct variation. You understand? We have direct, we have inverse or indirect, we have joint variation, we have partial variation. So by God's grace, we're going to be looking into all these things tonight, yeah, as God will lead us. Okay, so let's quickly go into direct variation. Now in direct variation, we tend to understand that as one quantity is increasing, the other quantity is also increasing. For instance, I want to travel from here to my village, okay, or maybe from here to Abia State. Okay, I'm from Abia State actually. So I want to travel from here to I'm in Enugu right now. I want to travel from my state, Enugu State to Abia State. You find out that if I will need a 1 liter of fuel, you understand, from here maybe to Soka, or from here to Enugu town. Find out that for me to travel from here to my place, Abia State, the distance has increased. The number of fuel I will also need will also increase. I hope you know.
Yes, sir.
Yes. So maybe I'm actually talking theory too much. I'm speaking too much English. Let me show you guys in calculation what I mean. This is what I mean. For example, this is fuel, and this is the distance I'll be traveling. Now, if it will take me 1 liter of fuel from my place where I'm staying in Soka down to Enugu, you understand? Let me assume it to be 10 kilometers per hour. Okay, 10 kilometers. Yes. Let me assume it to be 10 kilometers. If I know that from here now, if I go from here to UNTH, you know where UNTH is? UNTH is between Enugu and Abia State. So in there, I will need 12 liters of fuel. That will give me. That's because I'm 20 kilometers. You know. Now, if I go more, travel more, maybe to Osisioma, I will need gas. You know, and if I know that, because the distance will be to 40 meters. So if I know that as the distance increasing, the first one I traveled on kilometers was using 1 liter fuel. I increase the distance to 20 kilometers. I will need into 2 liters. The distance increase from increase to 40. I will need 4 liters. So you see that as one quantity is increasing, the other one is also increasing. Do we understand now?
Yes, sir.
Yes, sir.
Yes.
But sir,
Okay.
please, sir, what topic is this under?
What is
What topic is this under?
okay? This is variation. Variation. Maybe you just joined us now. I've already shown us what the topic is. The topic is variation, and we are talking about direct variation now. The topic is variation. Yeah, I hope you can see it. Yeah.
Yes, sir. Thank you, sir.
So yeah, it's fine. So we are talking about direct variation, and I said direct variation, as one quantity is increasing, the other quantity is also increasing. Yes, they increase in pari passu. Yes. So I want to be now. This is unlike indirect on verse. On day I will explain. In a verse, one quantity is increasing, the other one will decrease. Yes, as one is will decrease. Don't worry, we'll get there. Talk more about that. Okay, so let me share back this. All right. Okay, I have here. Emily said from her in Appleton. Her friend Kim, who lives 600 kilometers away in Bronzeville. She drives at a constant speed. Blah 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 blah. So you see that it took her 1 hour to travel a distance of 100 kilometers. For her to travel 200 kilometers, it will take her 2 hours. So for her to travel to 3 hours, 300 kilometers, it take her 3 hours. That's how it is. So as distance is increasing, time to get there will also increase. Yes, and it's applicable in real life. This is a real life scenario. So you find out here that something is happening here. Distance, the first one is 100, second one is 200, third one is 300. Something is happening. Look and tell me, it's increasing by 100. Do you observe that?
Yes, sir.
Yes,
Yes, sir.
yes, sir.
Yes. So that means this thing can be represented as a function, and this is a function. This is the function. Let me show you. Let me circulate. This is the function. The function is distance is equal to 100t. Yes, that's the function. A function actually means the formula, or yes, mathematical expression. That's what we call function in mathematics. What this function is saying that if I want to travel distance, any distance I want to travel is a function of time. That means if the time is 1 hour, the distance will be 100 kilometers. If the time is 2 hours, distance will be 200 kilometers. That's what he's saying. So I hope we all got what I'm trying to explain.
Yes, sir. Yes, sir.
All right. Okay, so that's that. Any other thing I need to explain? I think that's all I need to explain to you. Let's go down. I think that okay. Yeah, I've seen something I need to tell you guys. Another thing I need to say is that, let me share the screen. In variation, there's something we call proportionality sign. Yes, something we call proportionality sign. For example, now in this scenario now, I can say use F as my full as the symbol representing full, and use D as a symbol representing distance. Then I can say that F is very directly proportional to D. Yes. Do you understand what I've done now?
Yes, sir.
Yes. So we say that F, which is a full, varies directly to D. Now, this is called variation sign. This varies. If I want to remove this sign, I have to put what we call proportionality constant. Yes. Most textbooks use K. Some use alpha. It depends on what you want to use. You understand? But I prefer you use K because it is generally acceptable to use K. Most textbooks use K. You understand? So if I want to remove this variance sign, I'm going to have F is equal to KD, where K is what we call proportionality. Proportionality. This is proportionality constant. You understand? So that's for K. So anything in your solving, you need to get K first. That's the one I'm trying to say. You need to get this constant first before you solve. Don't worry, when we solve questions, you understand better. So, but so far so good. We are all good, Abi. Everybody on Natura, I'm trying to say.
Yes, sir, I did.
All right. Okay. Okay, moving forward. I have this. These are some examples that you come around. Yeah, now let's solve this question. This is an example. Yes, it's use the tables of values below to determine the constant of variation K in each case, and hence complete each of the tables. Now, some questions can come like this. Some questions can actually come in the table like this. Most times it doesn't come like this. Yes, most times it doesn't come like this. It will come in a written form. Raphael is raising his hand. Please, any challenge? Mr. Raphael, you're raising your hand. Any challenge? Can you unmute yourself and
I can't hear you, sir.
I can't hear you and I can't see your screen, sir.
Okay, you. I think the teacher is having a network issue because I can't even hear him also. Mm.
Please, Raphael, if you are not going to ask any question or answer any question, please unmute. Just mute your mic. Your mic was disturbing the tutor. Please mute your mic. Raphael.
Mute yourself now, this guy.
can you hear me, please?
Yes, sir.
Yes, sir.
All right. Sorry,
Please, who is chief? That person that is chief, please.
sometimes the
mute
question
your
can
mic.
come in that form. Who is that person? Please mute your mic now. What's that? So as I was saying, sometimes the question can come in this form, in tabular form. Most times it doesn't come in this form. It will come in the form of sentences. So we'll solve questions like this. We'll also solve questions like sentences, right? So let's start with this one so that you can have a better idea. Now, I'll have to solve it using the Canva so that you guys will see what I'm doing. Just hold on, let me clean this up. Okay, so now the question said, y varies directly as x squared. That's what I have. You understand? Please, maybe I need to show the question so that you guys can take a screenshot so that so that you guys can be seeing what I'm doing. Please, can you take a screenshot of the question? This is the one we are doing now. Can you take a screenshot? So you can be looking at it while we are solving. Take a screenshot, please. Fast.
Done.
All right. Okay, so now You understand? That's what he's saying. Let me go back to what I'm doing. So now next table. The table was drawn. We have our x and we have our y. So the question said when x is 2, y is 2. When x is 4, we don't know the value of y. When x is 6, y is 108. I want to believe this is correct. 108. Next, we are meant to look for x when y is 192. So we will do all this night now, just now. So now let's start with the question. We'll start with this. This is the function given to us. They will give you this kind of question, or they will put it in sentence form. Don't worry, when we solve questions like that, you understand. So here it says y varies directly as s squared. Now, to be able to go ahead to solve this problem, I'll have to remove this. I've told you that earlier. If I remove this, I will have to introduce what we call k, constant of proportionality. So that means y is equal to k x squared. Is anybody confused? I want to believe no.
No, sir.
All right. So now, having done that, this is your formula. You understand? Now, this will help us to be able to solve this problem. This first one will help us because we can't solve this problem without knowing the value of k. We need to know the value of k first. That's the first thing you need to do. Always solve for your constant of proportionality first. That's the most important. Now, how do we go about that? Come to this table I have here. This place I have value of x and y. I can use this one or I can use this one. The reason is that here I have the value of x, I have the value of y. I have the value of x here, I also have the value of y. In other ones, I have either the value of x or y. Do you understand now?
Yes, sir. Yes.
Here I will have to represent y as 12 and x as 2. So I have 12 is equal to k 2 2 squared will give me 4. 4 times k will give me 4k. Now I have to make k the subject. K now become 12 all over 4. That will give me 3. Yes. That means my constant of proportionality is what? 3. Now after solving for k, you have to restate your formula. This is a connecting equation. You have to restate it. That means my current equation now is going to be y is equal to 3r squared. This is my formula now. My authentic formula that I'll be using from now onwards. Is anybody confused?
No, sir.
All right. So let's move forward. Now moving forward. The question said they have already given us this one. We'll have to get this one. So now I have to find the value of y when my x is equal to 4. That's what this question is saying. Find y when x is equal to 4. So now let's go. Y is equal to 3 into 4 squared. So of course you know that this is going to be 3 times 16, Abi. I hope everybody's following.
Yes, sir. Yes, sir. Yes.
All right. So if we multiply 3 by 16, I have 48.
48.
Yes. So that means my y is equal to 48. When x is 4, y is 48. You feel here. Now the next question, they have already done this one for us. There's no need doing this. You understand? So here it says find x when y is 9. Sorry. Yes, find x when y is 192. So still using the same equation.
Sir, please,
I will do.
Please, can you scroll up?
Okay. Are you satisfied?
I mean, scroll up. Up.
Okay. Okay, like this.
Yes.
All right. Can we proceed now? If you're done, let me know.